Hello guys. Here we have an HP. It's not turning on at all. I tried, but it doesn't turn on. Anyway, you know the steps when we are dealing with a dead motherboard. Let me show you what we do. Laptop not turning on. These are the steps. So what you do first, you do a physical inspection. And guys, under my physical inspection, I've noticed that there is a benchmark. Some components are bent, but anyway, let's wear some gloves. All right, let's go ahead. Let's wear some gloves. Let's wear gloves. Gloves. Okay. Anyway, we have a bent spot here, a bent mark here. And one more thing. Let me check if we do have the schematic. All right, guys. I've checked. We do have the schematic. Don't worry, we do have a schematic. So surprised. Anyway, let me show you the schematic. Anyway, there's no need to show you a schematic. For now, there's no need. So what we can do, let's start on step number 1. Let's do a physical inspection together. I want to show you what I'm currently seeing here. I want you to see everything clean and clear. Let's switch to a microscope. Turn it on. The lights on. All right, here we are. Let me show you here. What do we have? Okay, ta-ra. Hey. Guys, I'm telling you. PD1 and PD3, I believe, is bent. Almost everything here in this area. It was bent, including capacitors. Wait, not capacitors. I think those are coils, inductors. So what you do, you put alcohol. We need to clean this area. It's so important to clean. You know why? So that you will have a better view, see a better sight, and see everything. You can see a spike. There was a big spike there, but I'm still confused on how possible this thing is bent. How possible that the power bends almost every component there on the DC inject. I'm still surprised by behavior. Okay, let's see. Okay, this power rail here is gonna be missing. Where exactly is going? I think we really need this power rail. It's so important. We can't afford to lose a single power rail, because we don't know how important these power rails are. It goes where? Okay, it goes from here to here. So this means, okay, what about here? What happened here? What about this one here? I don't think anything happened here, but this is gone. This diode here is gone. Even this one is gone. What about this capacitor here? I'm not sure about these capacitors, but these coils, I think these are coils. They are gone. Let's clean. Wait, this seems like capacitors now. I'm not sure. Guys, I'm telling you, this was a real mess. Hi boo. This was a real mess. But anyway, we have no choice. We have to fix this machine. Okay, so now what I can do is we can check for shorts. Let's check for shorts. You turn on your multimeter and then put it into a range of DC of continuity. There it is. You put it into a continuity mode, and then let's go ahead. Let's try. Let's check for shots. All right, you start from here. No shots. No shot to ground. Yeah, these are capacitors. What about this coil? Do we have a continuity here? Boo, it spins out. How come? Okay, let me double check if this was spent or not. Boo. Okay, this got spent. All right, now I understand why there's no continuity on this coil. I think because of the shorts. Okay, there's no continuity on this coil. I don't know why. Okay, but it's got bends. All right. Obvious, we have to remove this diode. And I'm not sure about this resistors. What about this diode? Seems to be fine. Let's rotate. Okay, seems to be fine, but obvious this is physically bent. There's no need to test this. You can see by your own eyes this is bad. All right, guys. Anyway, let's go ahead. Let's replace those components without a waste of time. Let's go ahead. I have the donor port. So now what we do, this is my favorite part. Okay, let's put some trim. Let's put some trim on those components. Let's put some trim, some juicy there on top. Let's put some trim. Let's put some trim. Okay, guys, this is not trim. This is flaxy. Okay. So let's put some flaxy there. All right. After that, what do you need? You need a tweezers. You need a tweezers. Let me try to make my tweezers straight. You know, these tweezers sometimes start giving you issues. All right. Okay guys, I will have to change this connector, so that's why I was spinning it. I don't care, because I will change it. I don't trust that connector. I'm not saying there's something wrong, but I don't trust that connector. That's why I will change it with another one, fresh one, because I'm still confused why there was so much spike here. Okay, I think I know why. I think I know what happened. I'm gonna show you the charging port. You know, they make a pin on the charging port. I mean, they make a hole on the charging port. All right, it means the charging pin, the charger from the charger side, it's broke inside. That tiny pin is broke inside the charging port. So I think that's where the problem started. Okay, now let's check for short. So let's check for a short to ground. Take your multimeter, switch it into continuity mode and diode mode, one probe to ground, and then you check. No short. Okay, can't see. No short. Now let's check for the continuity. Yes, there's continuity there. Okay, I believe everything is fine on this port. Now let's check one thing. I can see we have the first MOSFET and the second MOSFET and the current sensor. So let's have a look. Let's see, what do we have? Okay, no short on the 19 volt. Current sensor, no short. This is the current sensor for the 19 volt, and then this is the current sensor for a charge. Okay, it says PRB11. I do have the schematic. Let's check if the numbers are the same. If the schematic, it says the same. Let me show you guys. I want to spoil you, you know, you are my spoiled bread, so I want to make sure that I do spoil you guys. Let's have a look here. Okay, it says PRB1. This is the current sensor, PRB1. Let's go on the schematic and search for PRB1. But I believe this is for 19 volts, and the second current sensor here, PRB11, is for a charge. I mean, it's for charging the bed. I know for sure, but let's confirm and let's conclude. So let's search again. I said this PRB1. PRB1. Okay, I have PRB11. Okay, let's go back. This is a PRB11, and then PRB11 is for what? Is for a battery, as I mentioned. It's for a battery. Okay, it means I was right, but we have to confirm if we are using the same schematic or not. Okay, I can't see the current sensor. Or maybe my schematic is faulty. I'm not sure. Okay, let me check those MOSFETs. Okay, yeah, it's same schematic. Okay, next to this current sensor, there is a coil PLP1. Let's go on our schematic on our board and check PLP1. It should be next to PRP11 to confirm if we are using the same schematic or not. Okay, PLP1, yeah, we are using the correct schematic, so it means there is no short. I've concluded this means there is no short on the 19 volts, no short to ground on the 19 volts. Even here on the charging section, there is no short to ground, okay, that's good. Now let's check other power rails. What do we check now? Let's check the 3.3 and the 5 volts. Here the spot is so dirty. Okay, there's the BIOS chip. From the BIOS chip, you know how to check the BIOS chip, right? On pin number 8 is V in or VCC in. It means this where you will have the 3.3 volts or 1.8 volts. Let's check if we do have any shorts there. It's so important to check if we do have any shorts on the BIOS. On pin number 8, you check there for shorts. And there is a short to ground. On pin number 8, we have a short to ground. Pin number 8, we have a short to ground. There's pin number 4, but pin number 8 is beeping, and whereas it shouldn't beep, we have a short to ground. Hi guys, what about this? We have a short to ground. Let me put my multimeter there. I'm checking near the startup chip because I think the startup chip here is faulty. It's possible for a startup chip there to be faulty. Where is the 3.3 and 5 volts? Okay, this was the 19th. I want to check the 3.3. Okay, this is PL 100000. There's a short there. PL 1001. So what you do, you search PL. There it is. Okay, this is for 1.0 volts. Now I'm not interested. I want to check the 5 volts and the 3 volts. Where is the 5 volts and the 3 volts? I believe this is the one. PL 302. PL 302. Yebo, I'm right. PL 302. PL 302. It says the 3.3 volts always power rail. This is where the 3.3 volts is being generated. All right. Okay, so the 3.3 volts is shorted to ground. Okay guys, the 3.3 volts is shorted to ground. Normally what I do is very easy. I normally prefer to remove the CPU, I mean the heatsink. We're about to inject power without a waste of time. I don't like to waste my time, so let's go ahead. Let's see what is shorted, what is causing a short. But guys, this does make sense. I think it's possible for a startup chip to be shorted. You know why? It's because if you remember very well, there near the charger section where it's bent, there you have what? You have some lines sensing the battery, and they're all connected to the startup chip, if you remember very well. And there as well on that power rail here actually on the charging port where it's bent, we have what? We have the 3.3 is also connected there because it does communicate with a charger. The 3.3 there goes straight to a startup chip, and then it senses what? A charge. And if there's a short here, obvious, that whole short or that whole spike will go straight into a startup chip. Even the CPU as well is also connected somehow, but it's okay. I won't go deep. So what we do now, we're gonna inject power here. Let me turn on. We will inject power here. Okay, we'll inject power here, and then check on what will get hot. Okay, but without any doubt, I bet here the startup chip. I do suspect the startup chip, guys, because it does make sense. I'll be happy for something else, but I'm telling you, the startup chip here it's messed out. So let's find out. The one way to find out is to see and then stop assuming. Let's just confirm and be 100% sure instead of lying. You connect a wire there for our 3.3. Okay, so now what do we do? Connect your 3.3 here. Make sure you limit your power supply a little bit because you don't want to blow the whole thing, right? So be careful there. And then let's connect ground probe to ground. I'll use my hand to find out, but I'm so interested here on the startup chip, so I'm gonna start here on the startup chip. I don't know why, but guys, I'm telling you, this the startup chip here should be bent because it does make sense. I don't think it's a capacitor or a chip or anything. I think the problem is coming from here. Okay, there's a short. Okay, it's warm somewhere. Okay, let's increase. Let's allow more power. Okay, it's warm here. Or maybe it's my hand. Let me use this hand. No, true, guys, it's warm here. I'm surprised. Let's turn on the board. Is there any chance that the CPU is the one shorted? Because I told you, even the CPU somehow is connects. Not the CPU as such, but the PCH. You know this thing here, this one, the one that I'm cleaning right now, the one that connects with the 3.3, the PCH. But it's integrated into what? Into a CPU. So one side is CPU and one side is the PCH. Okay, let's see. This is so serious. Oops, this is bad. The PCH. All right, exactly as I told you. This is the PCH and this is the CPU, and the short is here. It can't be here because this is a CPU, but this is a PCH. It's connected with the 3.3 volts. That's why there's a short here on the 3.3 volts here. Short is connected straight here. There's a short with the ground here. This is a PCH side. It's connect with what? It's connect with the 3.3. The PCH works with the 3.3 and it's shorted. Oops. Ta-da. Okay, let me show you under the microscope. Let me just remove this before showing you because it's pointless. I like to clean my board every time when I'm repairing a board. I normally clean where I was fixing. Let's clean here. Okay, done. How? Imagine I'm removing. How I'm gonna show you the short now. Okay, it's easy. I'm just gonna inject it manually. Let's have a look. More alcohol. This is the PCH, and the other one, the big one, is the CPU. So observe here on the PCH. I hope you can see. Check there one more time. Okay, yeah, we have a short there, so nothing I can do. Because I can't replace the whole CPU for this job. It's not worth it, and I don't have the repolling machine, the PGA machine, so I'm not gonna waste my time. This is it, guys. It's so set, and it's so set. And one more thing with these repairs, I hope you can see that sometimes you have to have a PGA machine, but now the only thing that discourages me is that I was checking the prices. You know, the prices of CPUs. They are so expensive, man. They're so expensive. There should be a way. I'm gonna try to find a way. I think it's possible to use old CPUs from the donor ports, remove them, and then use them on the other machines. I know it's possible. I believe so. So I'm gonna do a thoroughly research. I like to research and learn new things. So I'm gonna do a big research before even attempting to buy a PGA machine. Okay, but again, I was wrong about the startup chip. Not wrong, because I was assuming I didn't have an assurance. But one more thing I like is that I removed the heatsink, meaning I was suspecting the CPU as well, the PCH as well. Because that spike there, I'm telling you, it spent so many things. So yeah, I was right on the CPU side, but wrong by suspecting the startup chip. I hope you learned something. This was a very, very nice tutorial. There was more things to learn because there was a short. It's not about those physically bent components, but there was a lesson there. There was a short on the 3.3 volts. So I was able to tell you on how to find the short and what are possibilities. Yeah, it does make sense. And I showed you nice, easy how to find a short. And I explained the short on the CPU, where exactly which part of the CPU, not the entire CPU, but some section of the CPU, a PCH side, which uses the 3.3 volts. Okay, so I'm just gonna stop there. And yeah, before I go, don't forget to subscribe and press the like button. Sharp guys, thank you so much. Take care.